All of you are welcome to Sanctum Institute. We decided to produce revision lesson series for chemistry students. This video is the general chemistry video revision lesson 1. What we are going to revise in this video? We are going to revise about atomic structure. What are the main topics will be discussed? First one is properties of cathode rays. Second, properties of positive rays. Then we will discuss properties of alpha, beta and gamma rays. And we will going to compare these properties. Then we will discuss observation of gold foil experiment. Then properties of electromagnetic rays. Then we will discuss electromagnetic spectrum. Then we will discuss quantization of energy. Then we will discuss de Broglie wavelength. Then we will discuss hydrogen spectrum. After this, we will discuss electron configurations. After discuss the electron configuration, we will discuss quantum numbers. Then we will discuss shapes of atomic orbitals. Then we will discuss history of atomic structure. Actually, finally, we will discuss history of atomic structures. Okay. We consider the properties of cathode rays. What are the properties of cathode rays? Cathode rays travel from cathode to anode in straight line. Second property, cathode rays are a beam of particles having mass and velocity, and also cathode ray possess kinetic energy. We can test this property by using the cathode ray with pedal wheel. Third property, cathode rays are composed of negatively charged particles. To check this property, we are using electric field. If we apply electric field, what happens? Cathode rays deflect to the positive charge. That means cathode rays are composed of negatively charged particles. After discussing the properties of cathode rays, we will discuss the properties of positive rays. What are the properties of positive rays? Positive rays are composed of positively charged particles. First property is the positive rays are composed of positively charged particles. Second property, charge mass ratio of the positive charged particle is depending on the gas which is taken in the discharge tube. That means mass of the positive charge particle is depending on the gas which we use in the discharge tube. Third property is the smallest positive ray particle is generated when hydrogen is taken in the discharge tube. That means if we use hydrogen gas in the discharge tube, we can get the smallest positive charge particle. Okay, let's consider the properties of alpha, beta and gamma rays. Property and compare these properties with alpha rays, beta rays and gamma rays. Charge. If you check the charge, alpha rays is the positively charged, beta rays is the negatively charged, gamma rays neutral. Mass of a particle. If you consider the mass of particle, alpha particle is equal to helium nucleus. Alpha particle is equal to helium nucleus. Beta particle is equal to electron. And and gamma rays also electromagnetic rays. Actually, gamma rays doesn't have the particle nature. It is the electromagnetic ray. Velocity. If you consider the velocity, if you compare the velocity, alpha rays the low velocity, actually lowest velocity. Beta rays are the medium velocity. Gamma rays, actually its velocity is equal to light rays because it is electromagnetic rays. Penetration ability. That means ability of penetrate the matter. The alpha particles penetration ability is very low. Beta particles medium ability. It has a medium ability. Gamma particles have a very high ability to penetrate matter. Okay. Then the alpha rays were used for the gold foil experiment. Actually, which was done by Geiger and Master. What are the observations of gold foil experiment? What are the observations actually? You can see the diagram. You can see the diagram. The diagram shows the properties, actually observations of gold foil experiment. Majority of alpha particles penetrated the gold foil. Majority of alpha particles penetrated the gold foil. Few number of alpha particles. Actually, few number of alpha particles deflected. Very few number of alpha particles bounced back in the direction from which it came. Very few number of alpha particles bounced back in the direction of which it came. Again, we consider the observation of gold foil experiment. Majority of alpha particles penetrate the gold foil. Few number of alpha particles deflected. Very few number of alpha particles bounced back in direction from which it came. Okay. These observations used to introduce the Rutherford's atomic model. Then we will consider the properties of electromagnetic rays. Actually, electromagnetic rays consist of electric field and magnetic field. We are considering the energy and the energy of electromagnetic rays, wavelength, frequency, speed of the light. If we consider the energy as the E, wavelength as the lambda or L. Some people use the L, some people use the lambda. Frequency, some people use the F, some people use the mu. Speed of light or light is the C. Some people use C, some people use V. Actually, C equal to F lambda or C equal to FL. E, energy is the E equal to HF or H mu. Mu is the frequency. H means the Planck constant. Planck constant is equal to 6.626 multiplied by 10 to the power minus 34 joule seconds. Okay. Then we we will discuss the electromagnetic spectrum. What is the electromagnetic spectrum? The actual electromagnetic spectrum is the display of electromagnetic radiation in order to increase in wavelength is called the electromagnetic spectrum. If we ordered or arrange the electromagnetic rays according to the increasing order of wavelength, we can get the electromagnetic spectrum. Electromagnetic spectrum is consist of light waves, ultraviolet rays, that means IR rays, infrared rays, IR, and the gamma rays, X-rays, radio waves, etc. Okay. Then we must consider the quantization of energy. What is the quantum? Quantum is the fixed amount of energy that can be emitted or absorbed by electromagnetic radiation. Actually, electromagnetic rays bring the energy as the quantum. Some people call this the energy packets. What is the photon? What is the photon? Photon also, which is like a particle of energy. Actually, particle of energy. It is called as the energy packet. Energy packet. Energy of a photon if energy of a photon is equal to E is equal to h f or h mu. Again, h is Planck constant. F or mu is the frequency. Okay, then we discuss the de Broglie wavelength. Okay, then consider the de Broglie wavelength. What is the de Broglie wavelength? Moving electrons act as the waves. Therefore, we can give the wavelength for moving electrons. If the wavelength of the moving electron we call de Broglie wavelength, if it's equal to lambda or L is equal to h divided by mv. Again, h is Planck constant. mv is actually mass, v is velocity, mv means momentum. That means de Broglie wavelength equal to h divided by momentum. These equations are important for the students who are studying chemistry, actually general chemistry studying students. Okay, then we consider the hydrogen spectrum. What is the hydrogen spectrum? In this case, we are discussing about the hydrogen emission spectrum. Hydrogen emission spectrum is a line spectrum. Hydrogen line spectrum can be explained by using Bohr atomic model together with Planck's idea that energy are quantized. Energy are quantized. Energy we can get the packets as the packets. Right. Now you can see the hydrogen spectrum. So this hydrogen spectrum actually consists of line series. Actually, it is a discontinuous spectrum, line spectrum. It can be explained by using Bohr atomic model and the Planck's idea, quantization idea. First line series is called as the Lyman series. Lyman series actually is in the ultraviolet region. Lyman series is in the ultraviolet region. The Lyman series actually rise as the falling of electrons from high energy level to first energy level. What happened actually in the hydrogen spectrum? How it's generated? Actually, if we supply the high voltage to H2 gas, hydrogen gas. This hydrogen gas absorbs energy and it will be broken into the hydrogen atoms. These hydrogen atoms also absorb energy and the electrons move to higher energy levels, from first energy level to high energy levels, absorbing energy. This energy absorbed as the electromagnetic rays. These type of hydrogen atoms are stimulated hydrogen atoms. These stimulated hydrogen atoms release energy, again it releases energy as electromagnetic rays. As a result of the Lyman series, Balmer series, Paschen series, bracket series, Puffin series. But I will discuss Lyman series, Balmer series and Paschen series. Lyman series is in the ultraviolet region. It is actually falling of electron from high energy levels to first energy level. Is the cause to the generate the Lyman series. Then Balmer series. Balmer series is in the visible region. It is also falling of electrons from high energy level to second energy levels. You can see the hydrogen spectrum and the Balmer series of the hydrogen spectrum. It is consists of H alpha line, H beta line and H gamma line. H alpha line is the cause of falling of electrons from third energy level to second energy level. Beta line is the cause of falling of electrons from fourth energy level to second energy level. The gamma spectral line is the cause of falling of electrons from fifth energy level to second energy level. Fifth energy level to second energy level. Then Paschen series. Paschen series is in the actually infrared, first infrared region. First infrared region. Actually, Puffin bracket series are also in the infrared region. But the Paschen series is the first series. Paschen series is generate the cause of falling electrons from high energy levels to third energy level. Right? You can see this diagram, energy level diagram. Energy level diagram shows this explanation. How to generate the Lyman series, how to generate the Balmer series, how to generate the Paschen series. Right? Lyman series generate the falling of electrons, high energy level to first energy level. Balmer series generate the falling of electrons, high energy levels to second energy level. Paschen series is generate the high energy level falling of electrons, high energy levels from high energy levels to third energy level. Okay. Then we will have to discuss the electron configuration. What is the electron configuration actually? Electron configuration is the electron arrangement. What is the electron arrangement in an atom? That means electron distribution. You can see the sequence of filling of electrons. 1s, first electron fill the 1s, then second s, 2s, then 2p, then 3s, then 3p, then 4s, then 3d, then 4p, then 5s, then 4d, like this. Right? I will give. You can see the simple diagram is in the video. Right? Then we will have to consider the quantum numbers. What are the quantum numbers? Actually, quantum numbers describe the electrons in an atom. We are using 4 quantum numbers to describe the probable location of an electron in an atom. Probable location of an electron in an atom. There are 4 quantum numbers. First one is the principal quantum number. The principal quantum number describes the electron shell or energy level of an atom. Second one is the azimuthal quantum number or angular momentum quantum number. Azimuthal quantum number or angular momentum quantum number. This quantum number describes the subshell of the electron. We can give the azimuthal quantum numbers for subshells. If the S subshell, it get the azimuthal quantum number 0. If get the P subshell, it get the 1. The D subshell, it get the 2. If the F subshell, it get the 3. Okay. Then next quantum number, third one is the magnetic quantum number. We give the symbol ML. The azimuthal quantum number get the symbol N. Principal quantum number get the symbol N. Magnetic quantum number describe the atomic orbital of the electron. Atomic orbital of the electron. Then spin quantum number. Fourth one is the spin quantum number. We give the symbol is MS. Spin quantum number describe the spin direction of the electron. Spin direction. It can actually get the 2 values. One is plus half, other one is minus half. Plus half or minus half. Okay. This the getting of these 4 quantum numbers show the diagram. If the if you can consider the P subshell, it has the actually 3 orbitals. That means 3 orbitals get the minus 1, 2, plus 1, minus 1, 0, plus 1. If we consider the D subshell, it has the 5 orbitals. It gets the plus 2 to minus 2. That means plus 2, plus 1, 0, minus 1, minus 2 as this. And if the F subshell, it has the 7 orbitals. You get the minus 3 to plus 3. That means minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3, like this. Okay. Then we must know the shapes of atomic orbitals. Shapes of atomic orbitals. The S orbitals are spherical shape. P orbitals are dumbbell shape. There are 3 P orbitals in one subshell. In one P subshell. They are arranged in the perpendicular to each ones. Perpendicular to each ones. Right? Okay. Then it is important to the exam history of atomic structure. Finally, we can discuss the history of atomic structure. Very important things. John Dalton actually introduced the golf ball model for atomic structure. Then J.G. Stoney, he named the electron W. Crookes. He discovered cathode rays. J.J. Thomson actually introduced plum pudding model for atomic structure. Plum pudding model. Actually discovered the ratio of charge to mass of an electron. He discovered the ratio of charge to mass of an electron. Actually, he is the person who discovered the electron physically. The Robert Millikan discovered the charge of an electron. He used for this purpose oil drop experiment. Some people call it oil drop method. Goldstein, he discovered the positive rays. Henry Becquerel or H. Becquerel discovered the radioactivity. J.H.W. Geiger and E. Marston actually had done the gold foil experiment or gold leaf experiment. Ernest Rutherford introduced the nucleus. Actually, he is the person who introduced the nucleus, atomic nucleus. He is the first person introduced the nucleus model for atomic structure. First nucleus model for atomic structure. He named the protons and he discovered the proton physically. He named the neutrons. James Chadwick discovered the neutrons. Moseley, he found the atomic numbers. Aston, he discovered the isotopes by using mass spectrometer. And the Max Planck actually introduced the quantum theory or quantum concept. Okay, today I have discussed the atomic structure. This video used to revise the atomic structure, right? You can